Okay, this week I'm going to talk about the history of voting, the mathematics of voting, and different types of voting. And this slide you see here is a list of kind of the overview of this video. I'll start off with two choices. Majority rules works fine as a method of deciding a winner in an election. But when there are three or more choices, majority rules does no longer guarantee a winner. We have several different methods of voting when there are three or more choices, and it's interesting to discover that the different methods of voting can produce different winners, even when the voters don't change their selections and their preferences. So these are the things that we're going to go through in this video, and so I'll start off with elections with just two candidates. So here majority rules will work fine unless there are an even number of voters. Right? Suppose there were 10 voters. That's an even number. It is possible to split the vote, 5 voters for, say, choice A and 5 for choice B, and then there would be no winner. But with many voters, the chances of an exactly even split approaches 0. So if you did have an even number of voters, you could consider some sort of method of a tiebreaker. But when you have two choices and you have more and more people voting, the chances of splitting exactly half gets smaller and smaller, and so that's not even really a concern. The real issue becomes when there are three candidates. Now, if there are three candidates, now you have a potential for what's called vote splitting, and that means that your electorate, your number of candidates, could break up it could split into a situation where the majority gets split, and then there is no majority. Right? So it's possible that no candidate receives a majority. So majority rules is not a legitimate method of voting when you have three candidates or more, because it's always possible that none of the candidates receives a majority. I mean, you could have a candidate get 60% of the vote, and that's a majority. You could have a candidate get 51% of the vote, and that's a majority. But it's always possible that none of the candidates has a majority. You could have the vote split, let's say 40% for one candidate, and then 30% and 30% for the other two, and nobody has a majority. So the problem is, even though every once in a while you can have a majority, it is always possible that nobody has a majority, and so you can't really say that you're using plurality. You're using majority rules. You can't say that it really is majority rules when it's always possible that the majority could split, and then there is no majority. So what we really do very often in this situation is what you're doing is you're looking for who has a plurality, and plurality just means more votes than anybody else. So with three or more candidates, we could look for a candidate with a plurality, and you'll see here that in fact that's not even the only way you could decide a winner. So let me make sure that it's real clear the difference between majority and plurality. Majority versus plurality. A majority is more than half. That's a majority. You could say it is literally most of the votes, being more than half, 51%, or even 50.5% or 50.1%. Anything over 50%. 50% is not a majority, but anything over 50% is a majority. And then a plurality is more votes than anyone else. And there you could say it's the most votes. So I really like that distinction to think about majority is literally most of the votes, and a plurality is the most votes. And they're so close in what they sound like, and many people don't even know the difference. And the difference is that a plurality is just more than anybody else. It isn't necessarily a majority. Right? So when you have three candidates, a plurality is certain. At least you could have two candidates that tie and have more than anyone else. But when you have three candidates, a plurality is certain, but a majority is not certain. Let's take example 1. Say we have an election with 3 candidates, A, B, and C. Suppose that 51% of the voters choose A, and 40% choose B, and 9% choose C. That adds up to 100%. And obviously, candidate A has 51%. That is a majority. That's more than half. That's a majority, and that's a plurality because 51% is more than anybody else. Let's look at example 2. Here's an election with 3 candidates, A, B, and C. Now, 40% of the voters choose A, 35% choose B, and 25% choose C. So A does not have a majority. A has what's called a plurality. A has 40%, which is more than anybody else, but it's not a majority. A has a plurality, but not a majority. In fact, the majority, which is 60%, choose somebody other than A, right? 60%, the 35, and the 25% make 60%, and that's the majority has split. That's a situation where you have the majority has split into the candidates B and C, and so you end up with A winning if you use plurality. Okay. So it isn't necessary that plurality is the only way of deciding a winner. So there are voting methods for elections with 3 or more candidates that we will look at where you can look at the one who has the most first place votes, and that's plurality, and that's what most people think of. But there are other methods, Borda count, instant runoff, sequential pairwise, and approval voting, and there's other methods besides just these, but these are very common methods that I would like to introduce. And it's not like these are theoretical methods of voting that nobody uses. All of them are used very often. Plurality is the one that is most often thought of, and it's used in most of the political elections in the U.S. But Borda count is a method of voting that's used in determining the top-ranked football team in the AP College poll. It's used in selecting the winner of the Heisman Trophy. It's also used for determining the baseball most valuable player in Major League Baseball. So Borda count is a very common method of voting. Instant runoff, that's how voting is done for the selection of the Oscars, for the site of the Olympics. And there are some political elections in California and Maine and Minnesota, to name a few, where the voting is done by instant runoff. Sequential pairwise is another method of voting, and this is essentially how the process of voting on legislation is done in Congress. And then there's approval voting, which, as an example where that's used, is selecting the United Nations Secretary General, which is the top position in the United Nations. Now, just a comment here about electing the U.S. president. We use plurality in each state in the country. Each state, you look at which candidate has the most votes, has more votes than any of the other candidates, and whichever candidate has the most, has the highest number of votes, will win that state. Right? So a candidate with a plurality of votes in each state gets that state's electoral votes. And each state has a different number of electoral votes that's based on the population of that state. And then the candidate with 270 or more electoral votes wins the presidency. That 270 number is actually a majority of the total number of electoral votes. And that's how the president is decided. Now I'm going to go through and look at each of these methods. I had 5 different methods: plurality, Borda count, sequential pairwise, instant runoff, and I'm actually going to do an example of each of those. I'm not going to do approval voting here, so I have 4 that I'm actually going to go through and do an example. And And so my first example here is introducing what's called a preference table, a preference schedule. I'm going to use the same preference schedule for 9 voters, and I'm going to look at 4 candidates, A, B, C, and D, and I'm going to go through all 4 of those different methods of voting and see who the winner would be with the same 9 voters, with the same preferences, and see what happens in each of these different methods of voting. So I want to make sure that you understand how this table works. What you see across the top is that there are 3 voters that have their first choice is candidate A. Their second choice is candidate D. Third choice is candidate B. And their fourth choice is candidate C. So that represents 3 voters, 3 different people with all the same choices. And then we have 6 other voters all listed out here that have their own unique preferences. So in this table, we're able to see every single voter, what their choices are, and if there are any voters with the same preferences, we put them all in one single column. Right, so we've got first choice, second choice, third choice, and fourth choice, and then all of the voters listed and how many voters have those particular preferences. Okay, so starting with that set of preferences, let's go through and see who would win with the different methods. Let's suppose that we were using plurality, the most familiar, the one that everybody knows. Voting by plurality means that you don't get to vote for your second choice, third choice, or fourth choice. All you do is you vote for just who's your first choice. And so with plurality, we consider only each voter's first place ranking, because a voter can only vote for his or first choice. That's all you do with plurality. And so I will only look at the top row here, the first choice of every voter. So I erase all of the second, third, and fourth choice don't matter in plurality. And now you just count up which candidate has the most votes. Well, I have candidate A gets 3 votes from these 3 voters and 1 vote from this voter, so that's 4 total. And you can see I have 1, 2, 3, 4, 5 other voters that voted for either B, C, or D. So A would win, right? A is the one that has the most votes because A gets 4 votes, B gets 2 votes, C gets 2 votes, D got 1 vote. So by the way, A got less than half the votes, 4 out of 9. But still, A got more votes than anyone else, so A would be the winner if you did plurality. A has the most number of first place votes. Okay, let's look at the Borda count method of voting. How do you determine the winner with Borda count? What happens here is in Borda count, you actually look at every voter's first, second, third, and fourth choice. And what you do is you say that if it's since we have 4 candidates, what I'll do is I'll say 3 points for first place, 2 points for second place, 1 point for third place, and 0 points for fourth place. So I'll look through and count up how many points does candidate A get, how many points does B get, how many points does C and D, each of them, get. So what's happening is these little numbers in parentheses are resulting from saying there were 3 voters who put A first. And so 3 times 3, that's 9 points. And there were 3 voters that put D second. So for D, well, D's going to get 6 points here, and so on, right? So then there are 3 voters that put B as their third choice, so that puts 3 more points for B. So I'm going to add up the total number of points for every single vote, right? For every single candidate. So looking at A, well, I got 9 points here, I got 3 more points there, because that's 1 candidate that put A first, 1 more candidate. So that's 9 plus 3, that's 12. Now A doesn't get any points here, it gets 1 more point there, so that's 13 points. A has 13 points total. Okay, let's look at B. Well, B got 3 points because there were 3 people that put him third, but then you notice how there was 1 person that put him second, there are 2 people that put him first, and 1 person here that put him second, and then 2 people that put him third. So actually there were 1, 2, 3, 6 people that put him third, right? Because you have 3 people here. So if you count up the total number of points, B is actually a little bit higher. in the overall ranking. In fact, if you look at this, there's a lot of people that put A last. Right? You got 1, 2, 3, 4 people that put A as their last choice. So A is missing out on a lot of points here because overall a lot of people really ranked A last. If you include this one, A put this voter put A as their third choice. So A did not earn as many points as B. B actually got 15 points, as you can see up here. If you tally up the total number of points, C gets 13 and D gets 13. Well, the winner is the candidate with the most points, and that's B, right? B has the most total points, so B is the winner with the Borda count method. So, already I've got 2 different methods, and I have 2 different winners, and these are exactly the same tables. Still 9 voters, the same preferences, but if you use a different method of voting, now a different winner would result. Let's look at another method of voting. How does instant runoff work? Well, instant runoff, what happens is you go through and you see first of all, if there's any candidate that has a majority, that would be the winner. Well, there is no candidate with a majority. We got 9 people and nobody has more than half of 9. You'd have to have 5 votes, and nobody's got 5 first place votes. So there's no majority right away. So what we'll do then is we'll go and look for which is the candidate with the fewest number of first place votes. And the answer is D. D has the fewest. There's only one person that put D first. Right? So we first eliminate the candidate D because the least number of voters ranked D as their first choice. So I'm going to cross out D. In fact, what I'm going to do is I'm going to cross out D for everybody, which is what I have here. So I've gone through and crossed out D in every single person's preferences and completely removed D as a choice because D was the candidate with the lowest number of first place votes. So if I take D out, no longer is a choice. But let's say that everybody's choices as they stood before would still stay relatively unchanged if you took out D. In other words, if these 3 people had A as their first choice and then D and then B and C, what I'm going to do is I will assume that A is still their first choice and then B is still preference to C, and so with only 3 choices now, I'm going to move up the 2 remaining choices, B and C, up to the second and third spot. I don't have to make any change here. For this voter, I'll say, well, if they put B first, they're still going to have B first. Then they're going to have C, and A is their last choice. And that would be the same for this person. This is C first, and then B, and then A is their third choice. And so all of those empty spaces, I'm just going to move up all of the choices below to fill in the empty spot. So it looks like that. So then I say, well, okay, now what's happened now is we've got 3 voters that said A is their first, B is their second, C is their third, and then there's 1 more person with exactly the same ranking. So I'm going to redraw the table and say there are actually 4 people that say A first, B second, C third. And then you notice there are 2 people here with B first, C second, and A third. And then there's 3 people over here that have C as their first choice. So let's redraw the table now, sorting all of the preferences into how many we have of each order. Right? So it's going to redraw like that. I've got 4 people that have A, B, and C in that order, 2 people that have B, C, and A in that order, and 3 people that have the preferences C, B, and A. Now, if there was any candidate now that had a majority, I would take them as the winner, but still, I don't have a candidate with a first place. So then I start again. This is the instant runoff. The runoff now is you're going to drop out the one with the lowest number of first place votes and do a runoff with the remaining voters. So, well, which is the voter that has the lowest number of first place votes at this point? Well, it's B. B has only 2 people that put him first. So we're going to cross out B. So that's what it says now. We begin again, identifying any candidates which have the least number of voters, ranking them in first. There could be a tie for the least. For example, if B and C were both ranked first by 2 voters, if if that had been the case, then both B and C would be eliminated and A would have been declared the winner. In this example, we eliminate just B because B tops only two voters' preference lists. So there you have it. You see, B is the first choice from the lowest number of people. So that's why I'm going to throw out B. So that's crossing out B. And if B is eliminated, then we'll have only two candidates, and we'll do a runoff between those two candidates. Right? So it's not like you have to do an election again. That's why it's called instant runoff. We're just recounting the votes from the preferences that have already been submitted, from the preferences that have already been given, that are already accepted. So when you take out B, now there's only two candidates, C and A. And when B is gone, I'll say that these four people would still have A as their first choice and C as their next choice. These two people would have said C is better than A, and these three people say C is better than A. So then what I'll do is I'll just put that together. Now I have 5 people that like C better than A. So moving up all the candidates into the empty spot and then looking at how many candidates I have, how many voters I have of each, of each type of preference. I have 5 that prefer C over A. So I'll redraw the table like this and say, well, now I have a candidate that has a majority, C. C would be the winner because C is preferred by 5 people as a first choice, and A is preferred by 4. So C is actually going to be the winner in this method of voting with these preferences. So now I've done 3 different methods with the same table, and I got 3 different winners, A, B, and C each time. One last method of voting, and again, realize that I have exactly the same table as before. I have the same 9 voters. I have the same preferences for each of those voters, which each of those voters think is the first choice, their second, third, and fourth choice. And I'm going to go through the same exactly the same election, but using a different method of determining a winner. Let's see what happens this time. This is called sequential pairwise. And what we're going to do is compare just 2 candidates head-to-head, pairwise. Okay, so it says up here, we must determine the order in which we compare the candidates head-to-head. And this is called the agenda. Suppose we compare them in alphabetical order. So the interesting thing here is even if we change the agenda, we could actually end up with a different result. So this is something that has to be given at the start, and then we can determine the winner based on using this order. So we have A first, then B, then C, then D. If we use that as the order, what that means is that I'm going to compare just A and B first and take the winner of that election. And the winner of that election goes on to face the next choice, and you compare those head-to-head or pairwise. And then the winner of that election goes on to face the next item on the agenda. So with the voter preferences listed below, we're going to begin comparing candidates A and B, as I said, just the first 2. So we consider all voter lists and note that B ranks above A on 5 lists, whereas A ranks over B on only 4, right? So I'm only looking at the preferences of all 9 people, all 9 voters, but I'm only looking at A and B. So if you compare these 3 people, they like A better than B. Well, here's another one that likes A better than B. That's 4. This person likes B more than A, B more than A, B more than A, B more than A. Okay. So actually I had 4 people that prefer A over B, and I have everybody else, 5 people that prefer B over A. So in that one contest between A and B only, head-to-head, if you compare A and B, this group of voters prefer B over A by a vote of 5 to 4. Right? 5 people, these 5, 1, 2, 3, 4, 5, those 5 prefer B over A because they all rank A lower. And these 4 rank A higher, but 5 beats 4. Okay. So B wins over A in that first contest, that head-to-head contest. So then if you look at that contest of A and B wins, then what happens is now we're going to take the candidate B and compare with C. So I'll do that next. So it's the same preferences, and I just compare only B and C head-to-head. If I compare B and C head to head, I have to look at, well, these three voters, they say B is better. This is one more that says B is better. There's one more. Actually, that makes 5. That's already more than half. Actually, there's another B better than C, and that's it. So I've actually got 6-3, right? If you compare B and C directly head to head, you got 6 people that put B higher on their preference. So B would win against C in a head-to-head contest by a vote of 6-3, and so B now is the winner of that contest. The winner of the first contest goes to meet C, and then B was the winner of that contest. So then it goes finally now to compare with the last one on the list. So if I'm going to compare B and D one-on-one, directly head-to-head, just those two, B and D, I'm looking at only B and D. So what I'm going to do now is say how many candidates put D higher and how many candidates put B higher, and take the one that's greater. Well, here I've got 3 that went for D over B, and well, I've got one more here and one more there. So that means I've got 5, right? There's 3 here that put D above B, and there's 2 more. That makes 5. So we find that D is preferred to B by a ratio of 5-4. Remember, I had 9 total. So once I get the 5, I know that I'm done because there's 9 total. So the other 4, that's the ones here in the middle. This is one voter with B over D, B over D, B over D. So 1, 2, 3, 4. These 4 in the middle prefer B over D, but you've got 5, right? You've got the 3 in the front here, these 3 voters, and those last 2 that put D better than B, and that means you've got 5 preferring preferring D over B, 5-4, right? So we find that D is preferred to B among voters by a ratio of 5-4, and because we've reached the last candidate, that candidate in that last contest head-to-head, D is declared the winner by the sequential pairwise voting method. So there you had it. I had 4 different candidates. I went through 4 different methods. I got 4 different winners with the same voters, with the same preferences. And the only thing that I changed was the way in which I was doing the voting. And so I think that's pretty fascinating. So is this at all disconcerting? Different voting methods producing different results? Candidate A won when I used plurality. So candidate A would say, plurality is the most fair. But candidate B won if you use Borda count. So maybe candidate B would have said, Borda count is the most fair because it really took into account all of the preferences of all the voters, first, second, and third, and fourth choice. And that's more fair. And maybe candidate C would say, well, the most fair was looking at who was the lowest number of first place votes and taking them out and doing a runoff on the remaining voters to see if there was any majority, and that's the most fair. And of course C wins if you do it that way. And finally candidate D would say, well, what we really should do is compare candidates head to head. And when you compare them head to head and you take the winner and then you go to the next candidate, that's a more fair way, because then you're only voting with 2 candidates, and you can actually consider a majority of does a majority prefer one or the other, and then only in that case would you then move to the next candidate. And so candidate D might say, well, that's the most fair, and of course that's actually the method that would make candidate D the winner. And the interesting also thing about the sequential pairwise is that it wouldn't even necessarily be candidate D. You could just change the agenda and you'd end up with a different winner. So which voting method is really the best, and how do we decide? You saw 4 different voting methods. Each gave us a different winner, and all for the same election with the same voters, with the same ballots, right? In all 4 examples, the voters were the same, the preferences were the same, and the ballots didn't change. However, with different methods of voting, the results were different. So the question is, do the voters really decide the winner? Or is the winner decided in a way just by which method of voting is used? Well, it's a long answer to say which one is the best, and it's not really clear ultimately really which one of these really is the best. I think that plurality is really not the best, but then it's difficult to now it becomes opinion because mathematically you can prove that there's always problems with all the different methods. I'm sort of partial to the instant runoff personally, in my opinion, but that's a topic for another video. So my point here was just to get across how many different methods there actually are, and that we really need to use those different methods when we have three candidates, because there isn't guaranteed a majority, and so it's fascinating to see the different methods that are actually in use, and it's also fascinating to see that they can actually give you different winners in pretty simple examples. Okay, that's the end of this video. I hope this was interesting and helpful.